Progress Check 5.2 Probability for GCSE Maths Foundation. Question number 1. In a box there are 24 cubes. 12 are yellow, 3 are blue and 9 are white. Without looking in the bag, a cube is taken out. So we have this number line here. So this represents 24 in total. That would be here 1 equal to 1. On the probability scale above, drag each colour to the position that represents the probability of picking that colour from the bag. So 12 are yellow. 12 is half of 24, so that's going to be going here. 3 are blue. 3 out of 24 is the same as 1/8. So I'm going to split this into half and this into half and half again here. So this would be 1/8, which is the blue colour. Then we have 9 white. So if this is 3, this is 6, so there comes the white colour. So this is 3/8. In question number 2 we have how many possible outcomes are there if a coin is flipped and the 6-sided dice is rolled. Here is an example of an outcome, H1. So for the coin we have either H or T, so heads or tails, and we have 6-sided dice which is either 1, 2, 3, 4, 5 or 6. So if I get heads, then I might have a 1. I could have heads and 2, or heads and 3, heads and 4, heads and 5, or heads and 6. If I get tail, I can get tail and 1, tail and 2, tail and 3, tail and 4, tail and 5, and tail and 6. So these are the possible outcomes. The question is how many of them. So counting them, 6 and 6 is 12. So the answer should be 12. In the third question we have there are 9 pens, 8 pencils and 6 rulers in a stationery box. A stationery item is taken out of the box. What is the probability that the picked item is a pencil? So first of all there is the pencils. So we have 8 pencils out of the total. What is the total? We have 9 and 8 and 6. So that is 23. So 8 out of 23. This is the fraction. You could write it as a decimal. So 8 divided by 23, which is 0.35, rounded to 2 decimal places. Or you could write 35% as well. So any of these versions is correct. The probability that the football team will win their next game is 0.74. The probability that they will lose is 0.15. What is the probability the game will be a draw? So the 3 possibilities are either win, lose or draw. And we know that they should add up to 1. So we already have 0.74 and 0.15. So we'll take it away from 1. And it gives us 0.11. So this is the probability the game will be a draw. On the school dinner menu, there is only ever one of 4 options. Some of the options are more likely to be on the menu than others. The table shows the options available on any day, together with 3 of the probabilities. Work out the probability of the dinner options being fish. So we have curry 0.36, sausages 0.41, fish, which is blank and we need to fill in, and casserole, which is 0.09. So we know that all of these 4 options should add up to 1. So I'm going to add these 3 probabilities that I have. So 0.36 plus 0.41 and 0.09. So all together this gives me 0.86. So I'm going to take this away from 1. And gives me 0.14. So the probability of the dinner option being fish is 0.14. In the next question we have, on a biased dice, the probability of getting a 3 is 0.5. The dice is rolled 350 times. So work out an estimate for the number of times the dice will land on a 3. 0.5 represents half, so half the time you'd get a 3. This means that if you roll this, theoretically, if you rolled the dice 350 times, half of the times you'd get a 3. So you could do this as 0.5 times 350, or you could do 350 divided by 2, which is the same thing. So that gives us 175. And that is an estimate for the number of times the dice will land on a 3. Question number 7. 2 dice are rolled and their scores are added together like shown in the examples below. What is the probability of getting a result that is an odd number? Write your answer as a fraction in its simplest form. So we have the first dice and the second dice. So the options are 1, 2, 3, 4, 5, 6, because this is what you get when you roll the dice. These are the possible numbers. And same thing on the other side. Now what we're doing with the scores is that we're adding them. So if you get a 1 with the first dice and a 1 with the second dice, you add them together, so that gives you 2. And same thing, if you get 2 and a 1, that gives us 3, and then 4, 5, 6, 7. 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, 12. So the question is, what's the probability of getting a result that is an odd number? So we're looking at the odd numbers in here. Change the color. So what do we have as odd? 3, 5, 7, 3, 5, 7, 5, 7, 9. You can see the pattern in here, so it's basically half of them. But we'll continue with this. So how many numbers do we have in total? That is 6 times 6, that is 36. So half of them, so 18 out of 36 are odd. So the probability is half, or 0.5, or 50%. Question number 8. There are 31 students who study languages. All 31 study at least one of Spanish, French or German. So all of these will be within the circles. No numbers outside of the circles, since all of the 31 study at least one of the languages. 4 study all 3 languages. So this is the area that is overlapping for all 3 of them. So we'll put 4 in there. Then we have 9 who study Spanish and French. So the area that is overlapping is this one in here. So we'll put 9 in there. 7 study French and German. So that 7 should go in there. 6 study Spanish and German. 7 study only French. And 5 study only German. So we've completed the Venn diagram. Now, the sort of questions that you could get that link to this would be to work out the probability of a student studying all 3 of the languages, for example, which is this one here, the 4. So that the way you'd work that out would be 4 out of the total, which is 31. So 4 divided by 31. Or you could have a question such as work out the probability of a student who studies French and Spanish, or studies 2 languages. So that would be looking at these in here, adding them up out of the total. So there are a range of questions that you could be asked in here, although this specific one is just asking us to fill in the Venn diagram. Question number 9. There are 150 students who are studying either maths or English. 83 of them are studying maths. So we can work out how many are studying English through that. So 150, take away 83, 67. 12 of those who study maths have passed the exam already. So we can work out how many have not passed the exam already. So we have 83, take away 12, which is 71. You can see that this is maths, and this is English, and this is passed, not passed. We have passed, not passed, based on the information we're given above. And we know that 12 have passed the exam, the English exam as well. So how many have not passed? So we got 67, take away the 12, gives us 55. Question is, how many students who are studying English have not passed the exam yet? And so we go through English, not passed, that is 55. Question number 10. Jim and Sue each take a driving test. The probability that Jim will pass the driving test is 0.7. The probability that Sue will pass the driving test is 0.6. What is the probability that both pass the driving test? And the quick way to do this would be to multiply 0.7 by 0.6. But there are other ways you could do this, and I'll go through the tree diagram method, which also explains why we have this. So we have Jim and Sue, and whether one passes does not depend on the other one passing the test. So these are independent events. So if we put Jim here and then Sue, or Sue and Jim, does not really matter. The order does not matter because they are independent. So Jim can either pass or fail. The probability of him passing is 0.7. Probability of him failing is 0.3 because they need to add up to 1. Then if Jim passes, Sue could either pass or fail. So pass, fail. The probability of Sue passing is 0.6. So the probability of failing must be 0.4. If Jim fails, then Sue can either pass or fail. So pass, fail. Again, 0.6 is the probability of her passing and 0.4 probability of her failing. So what we need to do now is to work out the probability that both pass the driving test. So I'll use a different color. Stick Sue and put the name here at the top. So we're looking at pass and then pass. So across the branches we always multiply. So we go 0.7 times 0.6 as we've got here, and this is 0.42. So that's the answer. The kind of other questions that you could be asked is to work out the probability that both fail, for example. So that would be going through fail and fail, so 0.3 times 0.4. Or the probability of one failing and the other one passing. So that would be fail and pass, or pass and fail. So multiply this across, 0.7 times 0.4, get the answer. 0.3 times 0.6, get the answer, and then add them up together. So these are just some other questions that you could be asked about this specific scenario. Question number 11. The table shows information about the year groups of 1,000 students in a school. Tony takes a sample of 50 of these students, stratified by year group. Stratified by year group means that you're using the same fraction again. So if we take year 7, for example, we've got 157 pupils. So 157 out of 1,000. So that is the kind of fraction that we're looking at. And we'll use this to multiply by 50. So you get the same fraction of 50 this time around. So this is one way. But there are other ways as well. Now the question is to calculate the number of year 8 students. So we're looking at year 8. So it's 180 out of 1,000. So we could have it as a fraction in there and then just multiply it by 50. Or we could convert it into a decimal first and multiply it by 50. Either way is perfectly fine. So 180 divided by 1,000, which is 0.180, times 50, that is equal to 9. So this is how many year 8 students he needs to include in the sample. If you get a decimal here, then you'd have to round the answer, because obviously you can't say 9.1 pupils. Question 12 is more of a statistics question rather than probability, but we've had to move this to this progress check due to the specific number of marks that we needed to have for one progress check. So we've got to write next to these pieces of data whether they are discrete or continuous. What is the difference between them two? With discrete, it can only be specific values, like the size of clothes, for example, or size of shoes. They can only have specific values. So it can be size 6, 8, 10, 12, 14, 16, 18 and so on for clothes. You can't have size 11 or 11.2 or 11.5. Or when it comes to shoes, for example, you only have certain values as well, so you can't have 6.1 or 6.2 or 6.345. So size of clothes is discrete. And so is the number of pens, because you can't have 2.3 pens. Whereas the height of a person is continuous, because you could have somebody being 182.35 centimeters tall or 1.7123 meters tall. So it's a range of values, not exactly specific. Same thing with the weight of an apple. So it can be 85 grams, it can be 86.12 grams, so a range of values